Okay. Okay, great. So yeah, let's start. Okay. To be honest, like to start with, I was like hesitating, right? Just should I talk about IoT and security because like so many articles, so many news about that. So everybody probably knows about IoT and security, right? And I realized that even now, like it's there, it's really to put it right, it's hard, right? Security is not really easier, right? And when you start to think about all the small things, like, and I thought, yeah, uh, let's just share my experience and just talk about this. Why not? So just to, I want to spend a couple of minutes talk about myself. Well, yeah, it's there, as we already know. My say surname is Russian, like Ilya Kudryavtsev. Originally, I'm from St. Petersburg, from Russia, right? Well, it's a big city, probably you know, right, in the northwest part of Russia. There was 5.5 million, I believe, or 6 million these days. And well, as we were joking just last week that when I arrived to UK, it was 1999, like 22 years. Oh yeah, no, 22 years ago. Yeah, now. Um, so I heard from a few colleagues, right, and also from my golf coach as well. So they were just laughing about this Ilya Kuryakin. And when I look on the internet, this was one Russian spy on some series, this about the spy series in late 60s, right? Yeah, just it's a really similar surname and the same first name. So there, let's just there. I want okay. Next slide. So I was got the degree from Polytechnical University in St. Petersburg. Also, I got the was on a student exchange program with the Technical University in Hamburg in Germany. And the interesting fact that when I took a train going back home, what happened that I passed there from Western Berlin to Eastern Berlin, right? And it took me another day to reach home, and I found out news that Berlin Wall fall down, right? And if I booked my ticket maybe 1 or 2 days later, I could stay in Germany. Who knows what could happen? And always like I was trying to try different jobs in a different company. So I was used to be like a sales guy and sales manager, account manager, involved in pre-sales, post-sales support, marketing, training, and support clients all over the world in Asia, like in South Korea, Singapore, in Australia, and United States, right, in Africa, and of course all over the Europe. And I got like say some experience in the companies like Apple, for example, right? And I drawn with the smart grid, smart meters, and that I always was like interested in everything related to the development, hardware and software development, firmware development. So the like IoT is probably a really good fit for that, right? And also that I started to use cloud, Amazon cloud, almost like 15 years ago, since it's started, right, just to provide such service. And I was like also quite interested in the AI, artificial intelligence, and machine learning. And my dad, who was the professor in the university, he explained to me about algorithms. It was end of I don't know, it's 1980 is right, probably. And I tried, even as I remember, just create the software. I just like playing, which could play chess, and I failed, but it was really great experience. At least I tried. Yeah. So, and here you can see that's my computer, which I put together right myself. It's Radio 86 because it was published in a radio. It's like electronic magazine in 1986. And I had just to buy components and soldering everything together, create keyboard, connect to the TV, right? And yeah, it was great experience. And funny enough, this computer got a 32 kilobyte memory, and Apple One, right? Which was assembled by Steve Wozniak and Jobs, right in the garage. She had like only 4 kilobytes of RAM. Like, yeah, so I was so like proud myself. And funny enough, a few years later, after I've done this, I joined Apple, right? The company Apple. So and also it was like sort of like it's nice experience to play with such computer, right? Because like it's a few languages were supported, like assembler, of course, like hex codes directly. It was like basic C and forth, etc. And it was quite funny that some software were printed in magazine, right, in a hex code, and I had just to type it, right? It was like the really old good days. But actually, it's they inspire me. Like a few years back, right? Just when I was playing with Arduino, especially Arduino, like Uno, which is a really basic one, right? It's a few quid for the device, and so only with a 2 kilobyte of memory. And when you know that you have to, when you create the software, you have to count for every single byte or bit even information, right? You need to squeeze all performance from all these resources, right? And I think it's the majority of the software development these days, right, and hardware as well. It's sort of like got a luxury that we can just drop, say, a lot of, let's say, megabytes or gigabytes even memory in the device, especially smart device if we're talking about IoT, and the storage, and we can run, say, create software using high-level languages like Python, for example, or Node.js, or this sort of thing, right? And yes, we have enough resources. It's a really good thing. Well, it depends, right? And we go to some details with that as well. So, and why we need to talk about IT security to start with? So, yeah, so IoT, which is Internet of Things, like it means any device which connected to the internet. So can we consider, let's say, a laptop or any computer is IT device? Maybe yes, right? Because computers got a camera and some sensors for sure. But normally it's when we are talking about IoT, it's just headless devices, right? Without any monitor, or very simple one, right? You cannot normally attach keyboard and do something for that and see the result, right? It's like a sensor, like smart sensor or camera, which is like doing the job and sending readings from the sensor or maybe stream of data, like the video stream, to the cloud through the maybe directly or through the gateway, right? So, and what is the impact of the IoT in our life and economy, right? So this is really staggering. So in this year, officially, it's very difficult, of course, to count that. Well, there are some statistics like 46 billion IT devices already in the world. Is it true or not? Who knows, right? It's probably roughly just, yes, the right number. And the market value over $2 trillion. And it is growing and growing very fast. So like in the next 9 or 10 years, number of devices should be almost like triple. And 35% of that is industrial IT devices. So just the industrial sensors in the factory or maybe in the buildings, right? Robots and all these things. So which is really, we rely on such devices and the reliability and security of these devices to trust that everything is going to work, say, smoothly, right, and a secure way and reliable. So by the way, there are rovers on Mars. It's also we can consider as IoT device as well. Well, only there is like some problems with that when you want even a pink rover. It takes like about 20-25 minutes to send the package there and another 25 minutes to receive the reply. But it's actually an IoT device, is perfect example as well. So, and 5G technology, which is really, say, almost like available in some areas and just around the corner for the rest of the world, it definitely will boost the deployment of such devices because they're now we can talk to each other, right? It's like creating mesh network using 5G technology, installed the edge devices at the edge with a really powerful like gateways or computers, and instead of the communicating to the cloud somewhere, right, maybe in the different country, they can talk locally, right? It's and 5G will improve significantly such architecture. And yeah, an amount of data is going to be collected. Also, just like it's mind blowing, right? It's like 80 zettabytes, right? Is going to be next few years collected, and it's almost impossible even imagine. So I want to tell you that just like how to even assess this amount of data. 1 petabyte of data, which is 1,000 times more than terabyte. 1 petabyte of data will cost 22,000 US dollars to store per month, right, on the S3 storage of Amazon Cloud, right? So if we are talking about the 80 zettabytes, it's going to be $1.7 trillion to store all this data per month on Amazon Cloud, right? And of course, like nobody is going to do that, right, without processing data and maybe deleting which is unused for sure. But it's there really, it's so much data is going to be collected. So, and security, right? It's there, even just like I took screenshot. If you just put on a Google search, IoT and security, it's like almost 250 million articles, right? You can find just, it's really, it's a lot of information there. You probably can find everything what you really want to know about the IoT and security there. And IoT, because it's the really critical part of the infrastructure, right? It's so many of them, and we are so rely on the reliability of such devices, right? So it definitely, it's becoming really critical that devices, so each device should be secure, right? And nobody is going to change anything on the device without proper authorization. So device is not going to be used as access point to the other resources as well, right? And as you can imagine, if we have already so many like billions and billions devices around us, it's not possible to replace outdated devices, old devices. For example, like even now, even today, um, in the industries, right, especially in the heavy industries and like old one as well, uh, still the vendors producing some sensors and devices which is supporting Modbus, right, which is really convenient. But Modbus was invented like over 40 years ago, Modbus protocol, and security is not there. So all these devices supporting Modbus, it's not really secure at all. So it's really a huge security risk, as you can imagine. So anybody can connect to the serial line and listen everything, all this data, or send command, for example, to the some control unit and switch on and off, maybe some motor or actuator or something, right? And the security is not there. It's not really part of the protocol. It's not really implemented properly. And this is like really, it's the big problem because we cannot replace all the devices, right, immediately. Right, it takes time. Even if we have, let's say, new devices which can say was developed properly, right, with the new hardware, with all the security, it's still It's we need just pay attention for all historic like legacy stuff. Well, some example, right? Amazon Smart Home. Well, it's, I guess like it's these days, it's some people, it's probably a lot of people already got the Alexa, right, at home, right? And even I have like a couple of Alexa devices, right, because I upgraded. So, and what the Amazon said, they already sold over 100 million Alexa devices, so Alexa speakers, right? And even I saw in some articles, they're claiming it's going to be probably end of this year 120 million. I'm not sure if it's true, but probably yes. And they've got like support for third-party devices. They got like 100,000 different skills, right? It means they can just ask Alexa what I'm doing, say at my home. And at Christmas, I have multiple switches around my house, in the garage, and outside and inside, and I connect like Christmas lights. And normally, like in the evening, I can say, yeah, Alexa, switch on Christmas lights, and yeah, everything is eliminated, which is convenient. Or Alexa set the schedule for Christmas light and say start like 3 o'clock p.m. right, and switch off whatever early in the morning. So it's really convenient way. But if every household, which is according to statistics, got about 10 IoT devices and connected to the Amazon cloud via Alexa, right? So it means we are talking about 1 billion devices, right, which is supported by Amazon only for Alexa infrastructure, right? It's this ecosystem. And the same probably we are talking, and if I start to talk about the Google Home. So it's definitely, it can be really big problem when you started to connect the well, random devices to your network, which is, you never know, right? It's what is software, what is firmware there, right? Is it really device trying to access your data, your network, scan everything around you, right? I mean, on the network, and just maybe steal some password or something? You never know, right? Hopefully not, but again, insecurity could be really, it's a big concern. Okay, another example. So there are, well, probably you know about the Boston Dynamics, right? And their latest robot, Spot, right? Like a robot dog. And just like I want to play a short video. So probably you're not going to hear any sound from this video, right? So, but so this robot's got the arm. It could have like a robotic arm, right? And you can see they can scan surrounding and find something like some stuff just like laying on the floor, can recognize what it is, and it's got a task like assemble everything, right? Pick up and just put in the basket. And here, like the multiple spots can coordinate themselves different actions, right? Like rope jumping, or even more difficult tasks like open the door and just trying just prevent the door slamming back and just get access to another room. It's pretty clever, right? Because it's only is possible when there's some AI is running inside this robot. Or in the some areas when the people are not really available or maybe dangerous, they can use this manipulator, just switch on and off mechanical switches like the lights or valve, right, on the pipeline. Okay, well, it's a little bit funny, just like they can dig, right, and like plant the small tree or whatever it is, right, and drag heavy stuff, right? It's the or the floor, yeah, and can paint, etc. So okay, just move on. So the Spot, it's just this robot. It's really perfect example of IoT device, right? The industrial IoT device. They got the multi-protocol support, can use the normal Wi-Fi, can access to the local network using like access point, right, as normal device, or can use mesh network between all these access points, between different robots, different spots, right? Got the built-in stereo cameras, so the operator can just using VR like Google's, right, or this helmet, right, just and can see in stereo mode, right? Can be installed like a thermal camera, which can be used to see if the some equipment can be overheated or not. It can detect animals or humans, right, in the complete darkness. Got like night vision with gas analyzers and can see that if there are some concentration of dangerous gases around, if humans cannot, people cannot be in this particular area, maybe in a factory, they can do some stuff and check if everything is normal. Can detect radiation. We've got AI, ML chip on board, of course, like can learn of the surrounding and just perform a task, right? And autonomous operation, so sometimes, of course, can lose communication with the access point, maybe can be underground in a tunnel or quite far away, and can do autonomously, can just have got a task and he knows how to navigate right around and just do the job. And it can be controlled via the special controller, or there is a normal server with API. You can create a program and can send command to the Spot, which started to perform this task. But what if this robot or system itself, including server, is hacked, right? You can imagine. So the Spot can search and locate particular object and person, right? Because like he's got the task, right? Just like locate someone, and he'll start to do so, right? And can coordinate with the different robots, so they can talk to each other. If somebody, like some Spot robots, can detect someone, can just send a signal to everybody else, so where this person is located. Can connect to the surveillance system, like surveillance cameras in the building, and just they see if what is happening in the different floors, even, right? I can turn on and off mechanical switches and valves. I can use lifts, for example, right? And can be used for the special operation. So you can imagine, like in this picture, somebody just installed a paint gun, but it can be a real gun, right? Or submachine gun, or like small rocket, or whatever, right? Or explosive. And you can say, yeah, it's sort of like really industrial stuff, which is used for, say, serious thing, and nobody is going to be stupid enough to use such thing like they put a real machine gun. Okay. So, and this is the pictures, right? It's how the Spot is used in New York and by police department. The middle picture, it's where it was like in the news maybe a couple of months ago in Belgium, military using Spot for some military trainings. And another one company in California, they're modifying Spot for the military operation, just to put the special equipment, maybe just upgrade batteries, etc., like motors inside, some protection from bullets, whatever it is. Right. So the people just started modifying this for their special operation for military usage as well. So, and the point is that the Terminator is not going to be like Arnold Schwarzenegger, right, anymore. The next generation, it can be really like small, cute robot, which is very, very, very useful around or even house, right? Or on the factory, right? And some building sites. But if it is hacked, it can be almost like ideal killing machine, right? And especially if we equipped with the guns, right, or some explosive, or can just the open valve, right, with the dangerous gas, right? This sort of thing, and you can start realize very quickly that actually, yeah, security it's a big concern. It's becoming even say bigger concern in the future. Of course, when more and more robots like that is going to be produced, right, and deployed all around the world. And what the Boston Dynamics said is after this news about the Belgium military, right, usage, so they condemned the portrayal of our technology in any way that promotes violence, harm, and intimidation, right? And they had to do so, it's for sure. But it's the which is good thing. It's definitely. But we need just to be careful, right? And to be sure that everything what is if we involved, right, as engineers to build something like that, right, or install, we have to be aware about the security of IT devices. Another example, which is probably it's quite old, like 6 years ago, it's happened. Ukraine power grid attack, but actually it's also related to maybe early version of IoT as well. So first of all, what is interesting. It's the first well-known successful attack on the power grid, and it's very well coordinated, right? And it took over like 6 months or almost like 7 months for this attack. So it's not really like in the movie, like bored teenagers just using computers hack Pentagon or CIA. No, it's a really well organized group, right? And they have motivation. They've got the funding to work on such project for many months, right? So what's happened? The attacker just sent the email to the one of the engineer, which was like field engineer on on the field. It was like I think it was repairing some substation or something. He's gotten his laptop some email. He just click attachment, right? Which we know these days that never click attachment from unknown person, and it was like Microsoft Word document, some file. And inside this file was like it's called black energy malware. And as soon as it was open, it just took control and just sent command to the website over the attacker, and started to spread over the network, right, and this utility company. And using the SCADA system, like supervisory control and data acquisition software, which control everything there. They got control to the substations, all the regional networks, right, and company buildings. And why they want to do so, that they were planning in advance that when they're sending signal to disconnect power, also afterwards they want to shut down the main building, all offices, and shut down the backup of the power, all these generators and UPS, right, just to prevent the operators can quickly reboot the computers and just send another command to override, right, the disconnect. And also they do figure out that there are switches which is connected to the internal network and controlling all these substations, right? It's just normal like Modbus to Ethernet adapters. And they created firmware and upload this firmware to the device. And firmware has got like special feature, right, which can accept on the disconnect command, and a reconnect is going to be rejected, just to prevent that operators again will recover from this fault of the software or from the system, SCADA system, send another command. So, but to do so, they had just to travel to the all the substations and manually upgrade the firmware. Okay, and finally, just before Christmas, right, this 6 years ago, the attackers finally they sent the command to the 27 substations and shut down all offices, and also they used the distribution denied of service attack to the call centers as well, to prevent that normal users started to report the problem. So the utility was completely, say, unaware what is the scale of this attack. And it took like many hours to recover everything. And like 250,000 customers, they were affected, right? Just lost power. And you can imagine how dangerous could be, right? Because like all infrastructure, like hospitals and buildings and factories just losing power. So it's really, really, really dangerous. So another classical example, right, again, is a few years back when the casino in which casino it's not really well known, right? It's classified information for some reason. Was hacked, right, using the fish tank. So like it's because like fish tank got like a few sensors like temperature, like amount of food there and cleanness of the water. And hackers, they were able to switch to the different network, which is connected to the internal system on some servers on the casino, and download and send about 10 gigabytes of data in some address in Finland for some reason, I don't know. So yeah, just it was like all over the news a few years back, how the some hackers can be really, let's say, inventive, right, and their attacks. Yeah, but it's funny, and of course as well. But the sort of again, it's you can imagine. So as soon as we started to talk about the security, it's really big concern that anything what you can see, like a fish tank, can be the penetration point for the hackers and can be attacked, right, and can be hacked. Okay, and this security design principles, right, which is like it's my top, so like a list, right, is which I always really like my favorite one. So first of all, security, it should be we need to think about security in the design stage. I know there are some temptations when you just create any device, right, hardware wise or firmware or software on the device, right. Normally developers are really concerning about the functionality, right. We need just to say read the data like from accelerometer and process all this data, and maybe we have to use like fast Fourier transformation to find out the vibration, right, frequency, and all these harmonics, right, as well. If over the time the frequency started to change, maybe we have a problem with this equipment, right? Maybe is the bearing, right, or something like it. Maybe it has some vibration, right? And like it's exactly what is calling preventive maintenance. As long as we can detect something abnormalities, right, and the behavior of this equipment, we can send a signal, some alarm, and say, yeah, okay, so something is wrong. We need just send some technician to check what is happening. But the problem is that as soon as developers start to concentrate on the functionality, they can completely forget about the security. And security should be one of the first feature which should be implemented, right, in the proper security mechanism. So any communication from the device, from the sensor to the local maybe server, gateway, and to the cloud via this gateway, everything should be secure, right, and should be properly secured, right, with the normally with the keys, with the certificates, right. Another thing, don't trust anyone. It means that any device which is on the field, which you don't have control, you need to consider as already compromised. So physically, if somebody has got physical access to the device, this person potentially can have access to the old security keys, right, to the memory, to the disk, maybe storage, right, if there is like disk or whatever just device is used for this to store data. and they can steal this credential and use for something else, maybe duplicate such device, right? And trying to connect to the cloud and steal some credentials from there. So it means every time, so what does it mean zero trust principle? So every time when the device is connected, it should be validated. Even if it just connected maybe a second ago, right? And passed all the security validation, we have to verify this again and again, right? Another thing, like don't reinvent the wheel. So it's shocking how many times I saw that developers with the, say, experienced developers, they trying to be smart and try to implement own security mechanism, right? And unfortunately, it's very, very difficult to do it right? So it means that we have to rely on the very well-known and open source algorithms. Don't reinvent the wheel, just use what is available. There are a lot of libraries in different languages. Just use what is available, but don't really try to be smart in the security. Another thing, obscurity is not security. And again, so many times I saw like developers trying to hide some algorithm or some keys or API keys, right, or passwords in the software, right? Even in hard coded in the code. And they sort of like saying, oh, it's okay, just we have like we can scramble everything and nobody's going to figure out what it is happening inside, which is completely wrong. It takes really little time just to sort of like open this sort of mess, right, and figure out what is going on. There are some tools for that as well, right? It's not going to take a lot of time. Password must die, right? So passwords, it should be only for humans, right? Well, it's but even so, there a lot of companies like Microsoft, Google, Amazon, they're trying to get rid of passwords using this different mechanisms, right? And definitely for IoT, I think it should be really no excuse to use passwords at all. The reason for that, it's not possible to change a password, right, in secure way. So it should be done properly with the PKI infrastructure, like public key infrastructure with the security certificates. Code base, every time when you create something, this is really like a big problem. When you create something like, say, implement a feature, right, in your IoT device or in your application, the developers, especially project managers, always under pressure, right, and some time constraints. They need to move on to the next feature and deliver this project on the deadline. And sometimes, probably more often than not, the developers trying to just skip this review process of the code and refactoring the code, optimize the code. And it will lead, of course, to the really big problem in the future, right? So it's going to be a mess code, especially when later on somebody will ask to modify this, add new features, and on top of that, it's going to be big mess. So from my point of view, even there you create something which is working, it's only 25% of the job done, right? Because the rest, it should be refactored, should be modified, should be tested, right, and tested again, and just to be sure that everything is done properly. Another thing that Brian Kernighan, right, the guy who created was involved at least in creation of Unix, and also he was involved in a C language, right? He said that you don't really want a nuclear power station run on Node.js. Why he said that? Because like it's nothing wrong with the Node.js as such, but there's a problem with the library manager, right? Like NPM. When you install something, it's very tempting. Like say, run one command, install all these libraries, right? And you can just in a few minutes, you can have your device connected to the internet and do some job like supporting all protocol, doing all this clever stuff. It's fantastic. But only the problem here, you can start to pull some libraries which is not developed by you, developed by third parties. And sometimes you never know, right? What kind of libraries you're going to pull on your IT device, right? It's going to be, say, megabytes and megabytes of code and 100,000 lines of code, which you're never going to even read through. And how you can be sure that everything is secure, right? And this is really another big concern. And I know it's almost impossible to escape such thing these days because it's the developers always under the pressure to deliver product as soon as possible, and very tempting just to use such thing like write the few commands and you can get all the framework installed, everything is good, but again, it's the very difficult could be supported in the future. So again, just going back one of the first slide when I showed the computer, which has got only a few kilobytes memory, and you have to be really inventive and save every byte for the memory and the resources just to deliver the same functionality, which is probably difficult, but it's the they make a difference between the normal IoT devices and great IoT devices. Okay, hardware security, again, there is no any excuse these days not really use security chips, right? And with the all security keys should be stored, right? Not in the software, right, but in a special device. Again, it's not really easy just physically secure a device, and there are some cases when the hackers will actually be able to decode some messages measuring the consumption from the power supply to the IoT device as well, right? And small spikes of the current, right? It's could give really enough clue what is going on inside. Yeah, I know it's so like crazy, but it's definitely it's real use case. Okay, and definitely is the data in rest and in transit should be encrypted, right? It's really obvious, and a lot of people just forgetting about that. Okay, and some security laws update for 2021. There are some laws in some countries, like in some states, like in the United States and California, for example, they have already a law that say all IT devices, they have to satisfy some requirements like no default password, etc., etc. And in the UK as well, right? We have update this year, which was developed by Department of Digital Culture, Media and Sport. And also they're working with IoXT, Internet of Secure Things Alliance, which got like 450 plus something member companies, including the really big corporation like Amazon, Google, Facebook, IBM, RM, etc. And well, it's 35 plus countries all over the world, right? And they've got some certification programs, so it's not really far from the future when any device which is going to be IoT device which is going to be sold have to have some security certificate and sticker, right? Just to prove that IoT device is secure enough to be connected to your network or connect to the industrial network, especially industrial IoT. I think is going to be the first one to adopt this. It's for sure. And they have security pledge. So that's the same thing, right? Is probably you already know there's like no universal passwords, secure all the interfaces, network interfaces, proven cryptography. Again, don't really reinvent the wheel. Security by default, so it means when device is delivered to the customer, it should not allow to connect without any proper security. And all passwords for the admin user should be unique per device. When a provision should be unique, right? You cannot have like admin, for example. It's obvious. Verified software, again, it's this going back to this example with power grid, right? So the device itself should not accept unknown firmware or software. It should verify signature of this package, right? So if it is not signed by the trusted vendor or developer, it should be rejected on a device level. Okay, automatic security updates. So all devices, they have to have security update over a few coming years. And one of the example, like if you buy, let's say, even a mobile phone, some phones, they normally people just, well, maybe change like every 2, 3 years, 4 years, right? These days, but some vendors, like especially no name, like Android devices, all right, they can just only provide updates for the first year or maximum 2 years, and that's it. And what are you going to do after this 2 years? So your device definitely outdated, right? And it can be like threat to your local network, because somebody can access to your local resources through this device if they connected to the network. And now it's going to be really required to provide such information, how long the vendor is going to support such device. And the customer can make a choice which device to choose, which is going to be supported only for 1 year or 2 years, whatever the minimum is going to be, or maybe 5 years, right? Or even longer. Like as we know, for example, Apple supporting, let's say, very, very old iPhones, all right, with the latest security updates, which should be, say, the case for any big vendors. And vulnerability reporting program. If somebody found the problem and bug or security vulnerabilities in IoT device, it should be possible to report this back to the vendor, and vendor should respond with some updates of the firmware or software, right, for the device. And security expiration date. Okay, so it's already actually time. It's almost like 1 hour. Hello?
Yeah, we're still here.
Okay, good. So because, like, again, just as I said, we have really a lot of things to talk about, and it really depends what we want to talk about, right? Just as and concentrate on the really generic stuff now, like probably like overview, right? Importance of the security in IoT. And I guess if we really want to go to the details, maybe some examples of the technical details, how it can be really hard, right? And what should be done properly, etc., etc. So, and maybe concentrate on the machine learning on the IoT devices. So it's the topic on another meeting. Okay. So okay, probably I'll stop here, right? I have some extra slides, but I don't think I have time. Okay. Hello?
All right, sorry, I was on mute
Dave?
again.
Okay.
How many more slides have you got?
No, just like I think just it's I think I need just stop because like it's already 1 hour.
It's fine. If anyone's got no objections, you can continue a bit more if you want, or we can switch to Q&A.
Okay. So yeah, I have like probably another couple of slides. So there just like few words about the passwords, right? So normally whether I use it for the some websites, right? Or if I just need quickly just set up some password on some Linux-based like IoT device, whatever, right? Just for the development or whatever. Just like I use like a password like this, like 60 random characters, right? So it's 16 bytes actually. But of course, definitely you cannot remember, right, such password, and especially when you have multiple sites or multiple devices, right? Can you remember like few passwords, 100 passwords? Of course not. You have to use like password manager for that. And again, it's these days, as everywhere else, and all these systems, you have to use the two-factor identification, right? Device might be your mobile phone, right, or your smartwatch, which can generate this temporary code, which is normally like valid for like 30 seconds. And yeah, and you need to re-enter this again. And for the device, again, the password, when the device itself is going to connect to the cloud, for example. As I said, it's still it's quite popular. Like developers, they can use like API key, right, for that, which it works pretty well for sure. But the problem with that how are you going to replace this key? Right, you can't. If it is compromised, you cannot send another key to the remotely to the device because, well, it's somebody can listen this communication. It's already compromised. So it means definitely the PKI should be used with a certificate when the private key is never ever is going to leave IoT device itself, right? And private key on the clouds never leave the cloud server. Right, and it's only the way. But even so, that talking about passwords, right? How they secure they are. It's just like it's like fun. So like slide. So there, this 16 bytes password, which is 128 bit, right, of information, which is commonly used even for PKIs as well, right? For this private and public key infrastructure algorithms. If we how long it will take to go through all combinations of this big number, right? It's 2 in the power 128. So and I found this really like interesting analogy. Like if we going to build ideal computer, what does it mean? Like bit. So it means it can be on and off, right? How about you can use one atom of hydrogen, right? For example, right? So to change the status, I mean, just energy status of the atom, we need just to apply some energy, right, for that. And well, it's pretty straightforward formula, right? You can find the Wikipedia. So there's the amount of energy should be applied to the atom to change the state. And now we need just to do this for the 128 bits, right? So for that, and we can calculate how much power we need just to go through all possible combinations from all zeros to all ones, or FFF, whatever, right, and hex, for only 16 bytes, right? So, and if we theoretically, we can build a Dyson sphere around our sun and capture all energy from the sun. And this energy will be required to be captured for 32 years to go the whole combination only for the 16 bytes. And we cannot do anything with this, right? Because we're going only through the combination, right? Because for every combination, we just maybe send to some function which can just validate is the right password or not. And of course, like as you can imagine, if such computer theoretically could be put on the surface of Earth, right? Everything is going to be evaporated, and all rocks is going to be melted. It's going to be like a blob of lava going around the sun, right? So this is like power of big numbers. And these days, algorithms using the even like much bigger number, like 256, right? Power to 256, which is probably, according to this Eddington number, right? It's amount of particles in the universe, right? Which is a huge, say, number, right? Just it's impossible to even imagine. But the problem is that even so, how it could be possible. So the password can be broken. The algorithm is broken because they are not ideal. This is the problem. So in ideal world, yes, it's not possible to break even the password with 16 bytes. But unfortunately, it's not the case because the function is not ideal. And why it's really, really important just to pay attention, right, on what has been done in this area, and don't really reinvent the wheel again and again, just trying to be smart. Just use something which is proven, and proven algorithms, right, and apply this carefully, right, according some guidance from, say, a lot of, say, companies. Like if you're building IoT, probably it's almost impossible to escape the Amazon, like AWS services or Google. I then have really, say, thousand pages of the documentation how all these IT devices should be built properly, right? Okay, this is the last slide. So do you have any questions, comments?
Any questions, anyone?
Sorry,
Oh, no, good.
I was about to ask, but I didn't realize my microphone was on mute. So you mentioned each device should have expiry date. What I should do and how I can check is my I have a couple IoT random devices in my home, which is light switch and a couple sensors. How I can recognize are they expired and what I should do with them after security will expire to them? Any recommendation?
Well,
can I?
Yeah, so that's
anything be done?
Yeah, sure. But only the thing, it's you need just to check with the vendor, right? Or the documentation. It should be there normally. And I know if you buy there's some, like cheap devices, right? I do it myself already as
That's
well.
exactly the case.
Yeah, so you never know. You need just trust. It's sort of like working. But there are a few vendors like SunOff, I believe, which is as on-off, SunOff, which is like I think they like it's a Chinese company. They're providing devices based on the ESP32 chip, chip and small PCB. It's very cheap device, right? Just like some switches and sensors. It costs like only a few quid. And the beauty of that, it's not only because it's cheap, and also the possible to very easy to connect to Alexa on Google Home, whatever. But also it's possible to flash your own firmware, and you connect to your own server, right? And you can be 100% sure their software is written by you, so you don't need to actually maybe write the software. Right? You can just download from GitHub, right, which is open source and very well tested, and say, yeah, just I want to create myself, and just put it there, and just to be 100% sure everything is good.
That's a good idea.
Yeah.
Okay.
But unfortunately, if you buy something, right, which is like closed source, yeah, you need just trust vendor, and you never know, right? It's really is true or not, right? What they claim.
Yeah,
just trust them.
I think I have that SunOff or some other Chinese company. So yeah, I can check later.
Yeah.
Okay. And the other thing is it possible to change if your IoT device uses PK public key infrastructure to connect to whatever it's required? Is it possible to change the key on the device?
Yeah, absolutely. So this is their thing. Like it's normally it should be done automatically, right? There are some like for example, like in Amazon, right? There is like even there's some like workflow, like change, like renew their keys and renew certificates. What is happening? The command is going to be sent to the IoT device remotely, like say, yeah, we need to renew certificate, either to use the existing key, which is supposed to be saved, right, on the security chip inside the device, and we can just trust it's there. That we need just renew certificate, maybe certificate expired, right? And it's also it can be done automatically, maybe it's in some advanced, like maybe a few weeks before certificate expired and it can renew itself. Or we can send the command like, please regenerate the key itself, right? And create the request to the cloud, which is going to be signed by some software, right? Or by vendor, for example. Yes, we can still trust this device. It can maybe verify the serial number is okay. So all these checks are okay. So we can maybe regenerate for maybe because we need to replace some of the components, right, on the field, right? And some serial numbers of this device could be changed, right? Because it's repair, right? Especially in the industrial world. And we need to regenerate this again, like, and recommission and attach to the cloud, right? So yeah, it's standard procedure these days.
Okay, so it's doable. Bill.
Yeah.
Thank you. Any other questions?
Can I just ask about Microsoft's Azure Sphere ecosystem? They've got a whole environment of design specifically for IoT, and how does that compare with some of the other offerings in terms of trying to defend against cyber attacks?
Yeah, so to be honest, I don't really was like have enough experience with the Microsoft and Azure cloud, right? Because like normally, as I said, I was working with Amazon like for like 15 years, and sometimes with the Google, but it's so like really prefer Amazon. Yeah, I know that Microsoft got as well, right? And I read a few articles about that, but it's I never to be honest, I never tried, so I probably I'm wrong person to ask about that.
Okay.
But the point is that these days, if we are talking about cloud and about the IoT, Amazon definitely the twice as big as any close competitor, Microsoft at least, right? And it's definitely is number one these days, right, in the cloud technology and IoT technology.
Okay. Thank you.
Okay.
Okay, any more?
Hi, sorry, Matthew here. Are there any companies that offer sort of third-party certifications that a company XYZ has actually followed a set of best practices and things like not storing passwords and code, really basic things? From a user's perspective, they can be certain that a company has actually done XYZ without them just physically saying, oh, it's Amazon, we should trust them.
Yeah, sure. Just there, it's well, it's the problem with that. It's not really. I mean, like it's very difficult, right? Just to like really force this law, right? Just even the school law, right? IoT law about the security, but it's very difficult to force it, right? As what to do with all these billions of devices already deployed, right? Okay, we're talking about the new one. It's sort of like gray area, like how you can just define which device should get certificate and should satisfy particular requirements, which one it should not really be so strict. right? It's sometimes like, I don't know, like, for example, like, because like all devices are different in terms of the computer power, right? And what they can do and how they can transmit data, right? And what they store, right? As they can imagine, for example, like temperature sensor, which has got really, let's say, little like CPU power, right? And memory and everything, which only can send every, I don't know, 15 minutes temperature, that's it. Right, and compare with the camera system, which can got the embedded maybe machine learning, can detect the some changes in the equipment, right, and like vibration, for example, right, the equipment on the factory, which is completely different things, right? And it's difficult to create like universal profile for everything. What IoXT, this guys they are doing, right? They've got like multiple profiles for the different type of devices. For example, say, what do you have to do to certify a device which is like your mobile phone? And if you want to certify applications, not only IoT device as such, they're offering certification for the application, how the application should be written in a way should be secure on your phone. Or it's smart speaker like Alexa, for example, or this Google Assist, right? And maybe just sensor, right? Or cameras, right? Like home cameras, or for the like a baby monitor, this sort of thing. They've got like another set of requirements. They're trying to differentiate the different type of devices, right, and applications. But again, it's really vague. Like it's sometimes it can be in the middle of this something. And well, it's I believe it's just a matter of time when it's going to be really forced, right? Especially for the industrial IoT, we will not be able anyone to produce and sell or upgrade device without proper certificate, right? When it's going to be forced, but I guess pretty soon, the next maybe few years, 2 or 3 years, I guess.
Yeah, thank you. Yeah, sure. Yeah. Seems like a sort of a black hole for the consumer to really know what they're buying.
Yeah. But again, it's not really any excuse just to trust that. Yeah, whatever you're going to buy, right, everything is going to be secure. It's not. It's you need just to treat this otherwise. Like, yes, probably something is wrong. And the good practice, by the way, if you buy anything like switches, for example, right, for your home or whatever, right, which is connected to the internet, Alexa, etc. They have to be connected normally on a separate Wi-Fi network, like a guest network, and it should not be able to access internal network, right? So, and again, it's these days, like all these routers, like even, well, relatively cheap, like say for £100, right? Started to provide a multiple internal network, which is separated. So, and again, it's if you're serious about security, I think it's we need just to educate ourselves how it should be set up. I know it's not really maybe concern for the majority of the people, but again, just if you really don't really want just your network is going to be hacked, right? And so something like ransomware is going to be installed in your laptop, right? Even at home, it could happen, right? You started to just pay attention to all these small things.
Yeah, thank you.
Okay.
Any more questions? Nothing?
Okay.
Awesome. Thank you very much, Ilya.
Okay. You're welcome.